magnetic toggling, the temperature of the fluid, and other factors will allow researchers and astronauts to further explore the frontiers of self-assembly. Touch the surface of your smartphone again. That's just the beginning. As you can see, our International Space Station is an unprecedented research platform in space, allowing researchers and scientists to conduct experiments that can't be done anywhere else. This work off the Earth will lead to a better understanding of the fundamentals of combustion, surface tension, and colloids in the absence of gravity, benefiting us by helping us to make more efficient combustion engines, better portable medical diagnostics, stronger, lighter alloys, medicines with a longer shelf life, and buildings that are more resistant to earthquakes. Research on the International Space Station continues to improve life here on the Earth. Be sure to stay in touch and follow us on Facebook and Twitter for the latest research news, and don't forget to download our app on your mobile device. Until next time, we're working off the Earth for the Earth.
I'm Josh Willis. I'm a climate scientist at the Jet Propulsion Laboratory, and right now I'm in Keflavik, Iceland, in front of the Gulf Stream 3, which we're using to conduct a survey for oceans melting Greenland. We have a series of points laid out where we would like to collect data, and by and large, we fly over those points and drop when we're right above them. However, in some places where ice or clouds are a factor, we relocate our points in order to find open water that's clear, where we know we're not dropping on top of a ship or anything, and we're able to drop through an area without sea ice. So in fact, when we have to change quickly because there's sea ice conditions or clouds in our drop point, we look out the window and look for places where we see clear open water and clear skies just above it, and we drop in those. So the team is sometimes targeting in real time, trying to find places that are close to our original planned drops, look for places where we see clear open water and clear skies just above it, and we drop in those. So the team is sometimes targeting in real time because of the range of the aircraft and the way the survey plan spreads out the ocean measurements. We really have to operate out of bases that are nearby and collect data that is not too long a trip for the plane. If we spend a lot of fuel flying out and flying back, then that means we have less fuel to actually drop the probes and collect data. So we've partitioned Greenland essentially into 4 pieces, north and south and east and west. We began by surveying the southwest part of Greenland, and we operated out of Qillspeed. We also dropped some probes on the way over when we flew from Bangor, Maine to Qillspeed. So we flew from Bangor to Kanger. So the Qillspeed was a very interesting place, but we were able to operate out of there for several days and really complete a large chunk of the southwest part of the survey, dropping several dozen probes over the course of 3 or 4 days. After picking up about 50 probes from Thule, we flew to Svalbard, Norway, a small island off the northeast coast of Greenland. From there, we were able to complete the northeast part of the survey, at least the parts that weren't covered with ice, and then flying across the northern edge of Greenland and surveying along the northern coast of Greenland on our way back to Thule. Then we spent several days in Thule, completing the northwest part of the survey, before yesterday flying right across the Greenland ice sheet to Iceland and landing here in Keflavik. We've set out a very ambitious plan here with the goal of dropping 250 probes in about a month. We're a little over halfway right now. We've dropped 150. We have 100 left to go and about 2 weeks left to do it in. So we're definitely beginning to feel the time crunch, but I'm confident that we can have a really excellent survey with just a number of good weather days.
This Week at NASA keeps you up to date. What NASA does, where NASA goes, what NASA finds. From humans living and working in orbit today to future journeys into deep space. From new scientific discoveries about our solar system and the universe beyond, to better understanding our home planet. From improving air travel to developing cross-cutting technologies for future exploration. When you're as busy as we are, a lot can happen in a week. This Week at NASA, on the air throughout the week or online anytime.
Nutrition and the role it plays to keep astronauts healthy on the International Space Station. Hi, I'm NASA astronaut Tracy Dyson. Welcome to Station Life.
Station 2 for velocity calculation. Go ahead and leave steps 3, 5, and 4, 6. We'll move it on to step 5.
You will go right now for that.
Copy. Thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
Good nutrition is a part of good health, whether you're on Earth or off. Today's show will focus on nutrition research aboard the International Space Station. That's one small bite for man, one giant leaf for mankind. Astronauts Scott Kelly, Kjell Lindgren, and Kimya Yui of Japan recently sampled the fruits of their labor after growing and harvesting a crop of outrageous red romaine lettuce from the Veggie Plant Growth Facility. This was the first crop of vegetables grown in space, specifically for the purpose of providing fresh vegetables for the astronauts. Later this month, the crew will harvest zinnia flowers, a precursor for the next crop. We're going to try tomatoes. changes our bodies in a number of ways. We lose bone mineral density, our muscles atrophy, our cardiovascular system gets weaker, and we experience immune system dysfunction. One of the ways of understanding the changes in our bodies during long-duration spaceflight is to study our nutritional status at specific time points during our mission. Samples that we collect while we're in space provide scientists with information on bone metabolism, oxidative damage, body chemistry, and hormonal changes. These insights give scientists a more complete picture about what's happening in our bodies. That increased understanding of the role of nutrition in adaptation to spaceflight has a broader application on Earth. One example is understanding the relationship of nutrition to bone loss. This is potentially valuable for people suffering from osteoporosis right here on Earth.
The bones in our bodies are alive, growing, and changing all the time. Our bones are composed of different layers. The outer surface of bone is called cortical bone. This is the smooth, hard part of the bone that we can see when we look at a skeleton. Inside the cortical bone is the trabecular bone. This type of bone looks like a sponge and helps to protect the bone marrow. The constant process of bones growing and changing is known as bone remodeling. This process is carried out by specific cells in our bones. Cells called osteoclasts have the role of breaking down our bone and removing any parts that need replacing. At the same time, cells called osteoblasts have the job of making new bone and helping to repair any parts of the bone that have been damaged. On Earth, in healthy individuals, this process is normally balanced so that the same amount of bone is made and broken down. In space, astronauts are exposed to lower levels of gravity than on Earth. This means that they have less mechanical stress put on their bones as they move around. Scientists believe that the bones naturally try to adapt to this new environment by increasing the rate that the bone is broken down by the osteoclasts. Meanwhile, bone formation continues to occur at the same rate as it does on Earth. The result is an imbalance in bone remodeling, which leads to an overall decrease in bone mineral density. While in space, astronauts can manage with lower bone density, but when they return, their bones are less able to cope with Earth's gravity. This increases the risk of fracture and injury. Scientists use many different tests to measure the density of the astronauts' bones. Results show that the astronauts, while in space, lose bone in a similar pattern to people on Earth who suffer from osteoporosis, but the astronauts lose it at a much faster rate. Scientists have found that exercise, when combined with good nutrition and increased vitamin D intake, is able to preserve some of the bone that was previously being lost. Since 2008, astronauts have been able to use a new exercise machine called the Advanced Resistive Exercise Device, or ARED. It is thought that this increase in force triggers the formation of new bone, bringing more balance to the bone remodeling process and allowing the bone density to stay at roughly the same level as it was before the spaceflight. It is a significant achievement to be able to maintain bone density in space, but more experiments need to be carried out to see whether the new bone which is formed in space has the same structure and strength as new bone which is formed on Earth. Understanding bone loss associated with microgravity may lead to better preventive care or therapeutic treatments for people on Earth suffering bone loss as a result of bone diseases like osteopenia and osteoporosis, or for patients on prolonged bed rest.
One of the things I love about the field of nutrition, one of the things that really drew me into the field of nutrition as a graduate student, was the fact that nutrition really is a cross-cutting science, and the fact that we get to look at all the systems and nutrition in and of itself. So doing bone studies and muscle studies and vision studies and cardiovascular studies really helps to branch out and to work with other groups and see the integration within the human being, and not just focused on a specific enzyme in a specific tissue in a petri dish in a lab somewhere in a basement. One of the great things about nutrition research on Space Station is that Space Station is a great platform in that it allows us to study very healthy individuals in a very strange environment, in a very unique environment that the body is trying to adapt to. And what that does, that allows us to understand how the body responds to these changes. And in many ways that reflects disease patterns or altered physiology, if you will, on Earth. So bone is a great example where when an astronaut is put into spaceflight, the body starts to break down bone because the body realizes it doesn't need the same skeleton in weightlessness as it did on Earth. And by looking at that adaptation and how to counteract that adaptation, that tells us about how the body responds to these different changes. So we see roughly the same change in bone in about 6 months on a space station mission as you would see in a much longer period, 4 or 5 years. So it's almost like time-lapse photography, where we can see a much faster glimpse of what's going on. We can study countermeasures much more quickly. And again, the implications of those studies for people studying those same phenomena on Earth really helps to leapfrog some of the technology there. Hi, my name is Scott Smith. I'm the lead for the Nutritional Biochemistry Lab at the Johnson Space Center, and we're studying nutrition off the Earth for the Earth.